All right, y'all, so this is going to be an example of how you could set up your green energy project. For my example here, I'm going to look at the cost difference between buying for providing the energy in the field for a electric car. I'm just choosing the base model Tesla Model 3, and a typical gasoline car. So I'm looking at kind of a base model Honda Civic right there. And I can go on their website, I can see the price of each of these, and it looks like we're looking at a difference here. The Tesla comes in at $43,000, the Honda comes in at $25,000, so finding the difference between those two. Really what this project comes down to is saying how long until those fuel savings, assuming it's cheaper to buy electricity than it is gas, is going to be equal to the difference in cost. In other words, I have to pay more money up front for this Tesla, but after a while, not buying gas is going to make it cheaper, and maybe this thing will pay for itself within a year or two. So really what we're going to be looking at for the Honda is my energy use and how that transforms into the amount of dollars it takes to drive 1 mile. We're going to be comparing that for the Honda and comparing that for the Tesla because I know a reasonable estimate of how much I actually drive. So for a gas-powered car, this is going to depend on the fuel economy, how many miles per gallon you get, or maybe we don't know how the fraction is going to look yet, how many gallons it takes to go 1 mile. And how much I pay for gas. Now, if we know we're going to be ending in number of dollars per miles right here, that tells me right off the bat which of these two fractions I'm going to use and which of these two possible fractions I'm going to use. I need to have miles on the bottom, and I need to have dollars on the top. So I've got to start with a good estimate for how many dollars it is to buy 1 gallon of gas. And I just so happened to pay attention to the street or to the gas station down the corner from my house this morning, and it's $3.87. Now that's a fact with finger quotes. All right, this is not always going to be true. Price of gas can go up or down depending on lots of things, but it's a decent estimate. I know it's reasonable because I saw it this morning. The other thing I need to know is how many miles a Honda can go on a gallon of gas. And of course, this is going to depend on whether you're going uphill, downhill, cold weather, warm weather, whether your tires are inflated, whether you're towing anything, or if you have a bike rack on it. But just looking at Honda's website, for this car, it says that I've got a combined mile per gallon rating of 36. So less in the city, more in the highway, but on average, we can expect to go 36 miles on 1 gallon of gas. And so 1 gallon of gas is going to be equal to 36 miles. And we can see that the gallon is going to cancel, and that's going to leave me with dollars per mile. And when you actually crank out the numbers on this, and I've got my little calculator right here, it winds up being 13, let's see. Sorry, let me come back over here real quick. 10 cents. I guess it's going to be $0.104 per mile. So basically 10 cents to drive a mile in your Honda. Next thing, we're going to do this for the Tesla. And Teslas obviously don't use gas, they use electricity. We know from class last week that power is the rate at which the energy is being used. It's how many joules of energy you're taking out of a wall socket or taking out of a battery every second. Well, that means that the amount of energy you're going to use, just multiply each side by time here, and that cancels, and energy is going to be equal to power times time. So the unit is going to be kind of silly here. I mean, we know the unit in metric is joules, and that's watts, and that's seconds right there. The electric company doesn't measure things in joules. A joule is a very tiny amount of energy. We learned that when we were lifting weights. They're going to measure it in kilowatt hours. So instead of multiplying 1 watt times 1 second, they multiply 1,000 watts by a whole hour to get a more useful measure of energy. And so it's known as a kilowatt hour. Excuse me. So what I'm going to have to do for this Tesla right here is instead of going dollars per gallon and gallons per mile, we're going to look at dollars per kilowatt hour and kilowatt hours per mile. So again, I know from my answer over here that I've got to have dollars on top and miles on the bottom. So not that one and not that one. I just have to figure out then how many dollars is equal to 1 kilowatt. Well, I get my power from Portland General Electric, and I just happened to Google up PGE rates, and it looks like the first ones are kind of cheaper. I'm assuming that I'm probably going to be using additional electricity to power this thing. So just for the sake of being conservative, I'm going to use this bigger number. 1 kilowatt hour cost me 7.05 cents. So I can come over here and say, I don't want to do that in red, I'm going to do this in green. 1 kilowatt hour is 0.07, let's say 705? Yeah, $0.705, right? That's 7 cents right there to drive 1 kilowatt hour. Now all I got to do for this Tesla is figure out how many kilowatt hours it takes to drive a mile, or how many miles you can get off of one of them. So I Googled Tesla battery capacity, and it looks like the base model, the cheaper one here, is going to be 50. I can fit 50 kilowatt hours of electrical energy into that thing's battery. So I'm going to have 50 kilowatt hours on top. As far as how many miles you can go on that, the Tesla's website says that this base Model 3, again, I'm not getting the long range of the performance, I'm just getting the cheap one right here. It's got an estimated range of 2.6 miles. So I can come down here and fill the rest of this out of 262, did I say 2.6? 262 miles. So similarly to how we did this with the Honda, I multiplied the cost of gas and how much 1 gallon of gas can take me to get dollars per mile. We're going to do the same thing here. This is the cost of electricity and how many miles that much electricity can take me. And when I multiply this all out, I actually get something a whole lot cheaper. So let's see, let me grab this dollar sign and get it out of the way. It winds up being like a penny, 0.013 cents or dollars per mile. So what we're seeing here, this Honda is taking you about a dime to go 1 mile, and a Tesla is going to take you roughly a sixth of that to go a mile, right? We're looking at like basically 1 penny to drive 1 mile. That's a difference of 9 cents per mile. So now what this problem becomes is essentially a Fermi problem. I know that every mile that I would drive in this upgraded Tesla is going to save me almost a dime. The question becomes how long until all of that fuel savings pays for the extra cost of the car. The Tesla's more expensive up front. I have to put more cash down, but I'm going to be paying less to fill the tank up, or the battery up, as it were. So really, this question says 9 cents a mile to save $18,000. Okay, that means I'm going to have to end in years per purchase upgrade, or years per transaction, or years per Tesla purchase, or whatever you want to call it. The things that I'm going to have to figure out is how much do I drive in a year? Well, apparently, according to the Highway Administration right here, the average American goes 13,500 miles per year. I have no idea if that's right for me, but if that's an average American, sure, let's go with it. So I know I'm going to have either miles per year or years per mile. I know I'm going to have either the amount of money to buy the car, or buying this car is going to take this much money. And I'm going to have either money per mile or apparently A-Lunch has started. 1 mile is going to cost you this many dollars. And I can flip all these fractions around and set this up to look like so. This is not really any different than your standard Fermi problem. And when I plug in all the numbers right here and multiply them, grab my calculator, it turns out it's going to take me, on average, 14.8 years to pay for one upgrade. All right, so the amount of money that I'm going to save by not buying gas and buying cheaper electricity instead will take 14 years to pay for this difference. Moral of the story, you're not really going to save money on this Tesla, right? It's going to take you like 15 years to pay for itself. There's going to be other benefits, right? You can take some comfort in the fact that you are not contributing to as much pollution, or maybe it's just cool to be gas-free. But what we're doing here today on this project is saying, how long will it take a green energy upgrade to pay for itself? Now, you don't get to do a Tesla versus a Honda thing. You can look at switching out a light bulb for a compact fluorescent bulb or for an LED. You could look at switching out a regular water heater for a tankless one. You're going to identify one green upgrade that you can make to your home and figure out how long it will take for that thing to pay for itself. Hopefully this was helpful.